Hi everyone. Today we'll be discussing the LeetCode problem of the day. Minimum number of increments on subarray to form a target array. So you're initially given an array target and you have an integer array initial of the same size in which all the elements are initially 0. So in one operation, you can choose any subarray of the initial array and increment each of the value by 1. So you just have to return the minimum number of operations required to form the target from the initial array. And the test cases are generated so that the answer will fit in 32-bit integer range. Yeah, so the answer will be in integer range only. So he's guaranteeing that. Let's just look at the first input. We have 1, 2, 3, 2, 1. We have to form this array, and initially we have the array with all zeros. So first we can pick a subarray to be the whole array and add 1 on each of them. So in first operation, we will add 1 on the whole array. And in the second option, we will pick this as the subarray and add 1 on each element. So it will be 1, 2, 2, 2, 1. And finally, in the third operation, we will pick just this element as the subarray. So here 1 will be incremented and the remaining will be same. So the total number of operations for this array is 3. So the output is 3. And this is the minimum operations we need. So let's look at the second input. We need to form 3, 1, 1, 2. And initially our array is all zeros. So first step, we'll pick the whole array and add all ones. And in second step, we can pick only this subarray so that it will add a 2 here. And in third step, we will pick this subarray. So that will add a 2 here. And in fourth step, we'll again pick this as the subarray. So it will add a 1 here. So it will become 3. 3, 1, 1, 2. So we can see our total 4 steps are needed to form the target. So our output for this is 4. And finally, let's look at the last input. 3, 1, 5, 4, 2. So for this, in first step, we can add all ones to the whole array. In the second step, add 1 on just this subarray. So 2, 1, 1, 1, 1. And in third step, we can add only 1 on this subarray. So we can't choose to add on the whole array, because if we do that, this value will get incremented, but this value should be only 1. So once the value gets incremented, we can't decrement it. So we have to use the increment operations wisely. So in the third operation, just increment on this part so that this will become 3 and all ones. Now in the fourth step, you can pick this as the subarray. So 3, 1, 2, 2, 2. In fifth step, you can pick this. So this will be 3, 3. In sixth step, again you can pick this. So this will be 4, 4. And finally, in the seventh step, you can just pick this as the subarray. So this will become 5. Let me just write the remaining elements. 3, 1, 5, 4, 2. So we have 3, 1, 5, 4, 2 as the target. And total we required 7 steps. So answer for this is 7. And coming to the constraints, the array length can be up to 10 power 5, and each element in the target array can be also from 1 to 10 power 5. Now let's go the approach. So suppose we have a target array as 3, 5, and 6. So let's go from the starting. So initially we have all zeros. So for this element to reach 3, we need at least 3 increments in this position. So in our answer, total we need at least 3 steps. 3 steps which will include this index. Now after that we have a 5. So in 3 steps we can make this 3, and we can also make the next value 3 by choosing this as the subarray. So that means in 3 steps I'm able to uh, populate 3 out of this 5 number. So the remaining I need is only 2 operations. So using 3 operations, I have formed this number, and since we need 2 more operations, I'll just add a +2. So 2 is the increment. So with this 2 more operations, I can now be able to form this number 5. So currently the total number of operations are 5. So in 5 steps, we are able to form this array 3 and 5. And the subarrays for this 5 is, first subarray we'll choose this, second subarray, third subarray, and fourth and fifth subarray. So after this, coming to the next number 6. So out of this 6 number, we can easily form 5 numbers from the previous subarrays. So like we discussed, we had subarrays something like this, like 3 subarrays like this, and we had 2 subarrays. So these subarrays will form 3 and 5. So we can simply extend these subarrays to 6, so that by doing this, out of the 6, 5 numbers will be already formed, and we only need 1 extra to form the 6. So to the answer, we'll just add a +1, which is 6. So that means after extending this, we need one more subarray on the 6 especially. So we can see that by doing total of 6 steps, we are able to form the array 3, 5, and 6. So from this, what we can see is initially our answer was 3. And then whenever our next element is greater than the previous element, we just need to add the difference to our answer. So here 5 minus 3, the difference is 2. So I'll add a +2 to my answer. And then we want to form 6. So the previous number is already 5. So we just need one more step required to form 6. So we'll add a +1. And total we have 6 steps. So from this we can say one thing, that if my nums of I is greater than nums of I minus 1, greater than or equal to, we can say, then in my answer I'll just add the difference, nums of I minus nums of I minus 1. So this is my first formula. And now let's look at the example where we have something like this 5, 4, and 2, which is decreasing. So we have 5, 4, and 2, and initially all zeros. Now to form the first number 5, we need at least 5 steps. So in my answer, it will be 5. And that means I will choose this subarray 5 times to add my answer here. Now the next number is 4, which is less than the previous number. Since my number is less than the previous number, I can just extend some of the subarrays here to form my answer. That means, let me just draw this a bit more clearly. So I had 5 subarrays on this 5. So out of this 5, I can just extend 4 of the subarrays. And this will also, by doing this, the number 4 is also formed just by using 5 subarrays only. And after this, I see my next number is 2. So 2 is again less than the previous number. So my previous number had 4 subarrays, and since my current number is less than the previous number, I can use some of the subarrays to form my current number. So to form 2, I can just extend maybe 2 subarrays further, and this will lead us to form 2. So from this input, what we can say is, if the current number is less than the previous number, then we don't need to add anything in our answer, because the previous answer only gets carry forwarded to the next numbers. So we saw that if the current number is greater than or equal to the previous number, we needed to increment what the difference was. And let me just write this also. My current number is less than my previous number. Then we don't need to add anything in our answer. So we can just completely skip this step. So, but I'm just writing it for clarity. So let's combine both increasing and decreasing and see what happens for this input. So after dry running this input, I think it'll be a bit more clear. So let me increase the eraser size and erase this. Okay. So we have the array 1, 4. Okay, 1, 4. What is 1, 4, 3, 2, 5, 6, and 7. So we need to form this array with all zeros initially. Yeah. So first we are on this number 1. And since it's the first number, we always need to have this many operations. So initially, my answer will be equal to 1. That means I will select this subarray. And by doing this, my answer will be 1. And after this, I see that there's an increment. So that is this case. Nums of I is greater than or equal to nums of I minus 1. So in our answer, we need to add the current number minus the previous number. So this much more we need. That means here we have 4. If I extend this subarray to this number, that means 1 is already filled and we just need 3 more operations here. So in my answer, I'll just add a plus 3. And by doing that, I'll add 3 more subarrays. And due to this, currently 1 and 4 is formed. So these two numbers are formed so far. Okay. Now after this, I move to the number 3. So here we can see that 3 is less than 4. Since my current number is less than the previous number, I can just extend my previous subarray further to form the 3. So maybe I can extend this subarray, this, and this. So you can note that so far I'm using only 4 subarrays, which is the answer so far. I'm not taking any extra subarrays. And by doing this, I have found my answer 1, 4, and 3 so far. And again, after that, we have a 2. So 2, what is happening? Yeah, so 2 is again smaller than 3. So again, we can just extend our previous subarrays to form this 2. So maybe I'll extend this subarray and this subarray. So I also found the number 2. I just move them side. Interfering, yeah. So after 2, now again we reached 5. So now we can see that 5 is greater than the previous number. So we are in the first case. So the 2 can only be extended, like only 2 of the subarrays can be extended to reach 5. So out of this 5, only 2 numbers are formed so far. So to form the remaining 3 numbers, we need to add a plus 3 to our answer. That means we need 3 more subarrays here. 1, 2, 3. So after doing this, we can see that the number 5 is formed here. And again, the next number is 6. So in the 6, 5 numbers are already formed by just extending our previous subarrays. So we can see 5 numbers are already formed. and we just need a +1 on this. So in answer, we'll just add a +1, and we can get this +1 by just subtracting 6 with 5. So 6 minus 5 is the extra number we need. So by doing this, we can form 6. And finally, we have 7. So again, for 7 also, if we just extend the previous subarrays, we already formed the number 6, and we only need one number extra. So we just add the one number extra to get the value 7. So by choosing these as the subarrays, we actually formed our answer. And if we counted 3, 6, 7, 8, 9. So total, we had 9 subarrays. And from this diagram also, we can verify. This is one subarray. This is the second subarray, third, fourth, fifth, sixth, seventh, 8, and 9. So we needed totally 9 subarrays to form this number. The logic is pretty straightforward. First, on the first element, we'll add it in our answer, and we'll start iterating on from the first index. And if my nums of is greater than equal to the previous number, I'll add my answer. Else, I won't add anything. And at the end, I'll just return the answer. Now let's code the approach. So I've already did the dry run for the input, for this input. So let's just convert this into a proper code. So first, let me take answer equal to initially target of 0. Let me quickly check the constraint. Yeah. So the array says at least 1. So we can safely choose answer equal to target of 0. And then start iterating from 1. So now let's check if my current number is greater than or equal to the previous number. So if target of I greater than equal to target of I minus 1, in that case, in my answer, I'll just add the difference, which is target of I minus target of I minus 1. And else case, we don't need to add anything. So I'm just skipping that. At the end, just return answer. Let me just comment this. Also, if my number is equal to the previous number, we are anyway subtracting it. So anyway, this value will be 0. So there's no point in mentioning the equal case. So we can just mention the greater case. So if it is greater, we'll just add whatever the difference is to our answer. Let me test it. Works. Submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, we are just running a loop on the array once. So it will be order of n. And for the space complexity, we will have order of 1 because we are just initializing one variable answer and just the iterator I. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. Let's catch up in the next video.